All these diagrams that we've been looking at so far, they are describing the system from a static point of view, right? They're not considering at all the passage of time. Right? They say that this is the data that we have, and it's related to other pieces of data in such a way, right? That for every single provider, we might have multiple services that provider is providing. Right? It doesn't say anything about how services come and go, or how the state of the system might evolve over time as these things happen. Now, sequence diagram is one of several types of diagrams that describe the system as it's evolving over time, or how is it that it interacts, different parts of the system interact with one another, okay? And what events might be sent but between the different systems and how they might react. So they allow us to describe messages that flow between different systems over time, in this by using by showing different dependencies between classes, different components, subsystems, or different actors as they interact with the system. So here's an anatomy of a very generic sequence diagram, where you might have a stick figure, which is not shown here, that might represent a user, and that user might be sending, as they interact with the browser, or they interact with the user interface, as they click on buttons and submit or forms or fill out forms, they might send an event to a browser or a window or some user interface that might give them some feedback at a certain time. Here we have time flowing from top to bottom. Right, so time progresses down the screen over here. From left to right, you have different what are called swim lanes, right? That show the different classes or different components or different instances of objects as they interact with one another. And here are these are a particular execution of that particular object as it's presumably comes into existence, does some computation, and then dies, goes away. And we can show here how the events are being sent over from one system or object over time. So here's a validate. That event that is received by the window object, which sends another validate event to the JavaScript component, and then creates an instance of a brand new object that lives for a while, and then might die after a while, where you might have an explicit X that shows that the life cycle of that object has completed. Sometimes you might have dashed lines to describe that there's some kind of passage of time. Some of these messages might be asynchronous, in that we send a message, and whoever sent the message is blocked, waiting, right? Is blocked, it cannot continue computation until there's a response from the object that was invoked. Some other invocations might be asynchronous, where the event might have been sent to a system, but the caller doesn't wait for the other system to respond. And instead, it might register a callback with that system, where it depends on that other system to call back at some point and notify asynchronously that the process has completed. In this particular case, the method was sent over, or the message was sent over from JavaScript, but notice that the response actually is being handled by someone else. Right? So here the create or the sent over the message is not even being handled by the object that called. Instead, it was registered by someone else that is going to receive that message. So yeah, so here's a couple other things here. You can have blocks, right? We can have interaction blocks that allows us to add conditional execution, where if a particular condition is true, then that block executes. Otherwise, it does not. Or it also allows it to describe loops, right? That we stay within the loop as long as a particular condition is true. So let's take a look at those. All right, so consider the same example that we were looking earlier about the coffee shop and the different actors that are interacting. We have the barista, we have the cashier, we have the customer. All three folks interacting with one another, interacting with the point of sale. So here's an example on how you could document some of the interaction between these various users. The customer interacting with the cashier interacting with the barista, and then the barista interacting with the customer. And all these different events, it might be events that are just spoken events, right? As folk interact with one another in speech, or it might be actual interaction with some system as you use gestures and keyboards and mouse and whatnot as you enter data into a point of sale, into a register, and the register then responds to you, and then the cashier then responds to the customer. Some other systems that might be part here, for instance, in our case, in the assignment that is going to go out today, you might have interactions between users and their browsers and some web service that is receiving some HTTP requests, the system interacting with a relational database and storing this data or retrieving it and then going back to the browser to be rendered in this case, or it might be just a postman as it interacts with the system. Here's conditional flow where you box in an entire set of interactions between various systems, and these blocks are guarded, right, by conditionals. That if that particular guard or condition is true, then that particular block executes. So for instance, here we have two blocks that I would execute only if that particular guard is true. For instance, you might pay by cash or you might pay by card. If that's true, then one of them executes and not. One of them might entail having to interact with a financial institution if you're paying by a card. But if you're paying by cash, then no, you just interact there with that person, and you would show the interaction with these systems if interacting with the financial institution if you're paying by card. So yeah, these are called guards. Right? A guard is a condition that must be true for the alt to execute. It is an alternate path. You can also use the same idea, right, to model loops, things that need to occur multiple times or occur like iterations or while loops or whatnot, right, where you can use the guards as the condition to stay within the loop, right? If the condition is still true, you stay in the loop. When it's false, then you would continue. Make sense? All right. So as part of the assignment, you will be using these types of diagrams to document certain things that you're going to be building throughout the sprint. Oh no.